Hello, everyone, and thank you all for joining us today. I would like to welcome you all to a very special Pride edition of IBM Visual Insights, Deep Learning in AI Vision at Blazing Speed. If you take a look in the chat to the right, I've posted the links to the workshop slides, as well as a custom link to create an IBM Cloud account. And I've also added a link for more information to the IBM LGBT+ Allied Championship Practitioner Badge, which we will talk about in more detail in just a minute. I have posted a question for you all in the Ask a Question section at the bottom of the page. I'd just like to ask all of you where you're joining from today. I'm currently in Western New York. Mike, our speaker for tonight, he's joining from Austin. I know we have some IBM Developer advocates in the chat today helping us out, joining from a few different cities as well. New York, Ann Arbor, very cool. So welcome, welcome. To get started, I would like you all to share a little bit of information about yourself in the chat, so we can all get to know each other a little better. So if you would be so kind as to share your name and your title and company, or maybe you're a student, which program or school you're in, maybe you're in a coding boot camp, where you're from or where you're joining from, something you love, and a quirk, something that's uniquely weird or different about you. I will add these in the chat as well so that you can reference them. Oops. There you go. And while you're getting to know each other a little better, sharing some more information about you, I'm going to answer a few preliminary questions that most people ask, and share some resources with you before we get started, and then we'll do some introductions. So to start, again, this is the link to the slides. This is also posted in the Ask a Question section at the bottom. It's also posted in the chat, so you can find it in a few different places. If you don't already have an IBM Cloud account, it is free. If you would like to sign up, please use the link above here. We have a free light tier account available to everyone and anyone that would like to use IBM Cloud and any of the services in our catalog. And this is kind of what to expect when signing up. So we're going to go ahead and get started with introductions, and then I'll pass things off to Mike to take you on your computer vision journey today. So here's the link for more information about our allyship badge at IBM. We will be talking more about that in just a minute. Just wanted to share that link with you also. It is also in the chat. So first, let me introduce myself. So who is this person that's been talking at you for the last 4 minutes? So my name is Jenna. I'm a developer advocate with IBM. I'm currently working from home in Portland, New York, outside Erie, Pennsylvania. I am part of the New York City advocacy team. I recently joined about 6 months ago. Prior to that, I was working on cloud infrastructure team, software team in Austin at the IBM Innovation Center there. I've been there for about 2 years. I'm a non-traditional person in tech. I left Detroit, took a gamble before sending out med school applications, and went to a coding boot camp. Got really involved and excited around hackathons and workshops, and then found myself at IBM joining through the Tech Reentry Apprenticeship Program. So something I love, something thing I love are my dogs. I have little Yorkies. They're old now, but they're still little and they still look and act like puppies, which is great and can be very annoying, especially when I need to work. And then a quirk, so something uniquely different about me. Those of you that have joined sessions before, Clayton, I see you here. We've discussed this. I have an obsession for tuna sandwiches. I think I had a tuna sandwich the last 2 sessions. I did not have one today. But I love a good tuna sandwich, tuna salad or a melt. And if it's on the menu, I have to order it. And if it's bad, I won't go back to that restaurant. I just judge the quality of the rest of the food based on how much love they put into a good tuna sandwich. Yeah, so thank you all for coming. It's good to see a lot of you that we've seen before. And to those of you that are new, welcome, welcome. Thank you for coming today. And I hope you learn something new and have a really insightful evening. I would like to pass things off to Mike so he can get started, share more about himself, and then facilitate the talk for the rest of the evening.
Sure, thanks, Jenna. So I didn't write the title on this slide, so the do data science stuff and all that, thank you for that. So yeah, my name is Mike Hollinger. It's a pleasure to meet everyone here, and I look forward to having an interesting conversation in an evening with you. I'm going to share my screen and share some content, which we will use to go through our conversation. So first, let me just give you a little bit of an introduction. So my name's Mike, and I'm one of our principal architects now, actually, for computer vision in IBM. What that means is that it's my job to help design software and help systems that are leveraging that software to go out into a given customer's hands and help them to solve a problem. That might be in a different domain like energy and utilities, or it might be in a research sort of setting like at a university, or it might be in a startup. But at the end of the day, we build software for our customers to use, and it's my job to make sure we do the right thing. So today, I want to share a couple of different things and then leave time for questions. So there's the Q&A built into the platform. Please feel free to ask questions. Jenna's going to help moderate that and make sure that if there's something really cool, she'll pipe up and make sure I don't miss it and it doesn't go flying by. So please ask away, and we'll dive into wherever you want to go and dive into that in any depth. First, though, let's talk about the current moment. So part of why we're here is that IBM arranges and has a structure in place for something we call a business resource group. Other companies might call them employee resource groups or diversity networks or something along those lines. I actually am also, aside from my day job, the co-chair of out at IBM Austin, which is the LGBT+ employee resource group for friends, allies, IBMers, IBM alum out in the community here. We put this event on our calendar a long time ago with Jenna, and we did it as part of Pride Month. June is a moment for us to take a step back and look at the struggles that as a community we've overcome, and look at the places that we've come from and where we're going to. Given everything that's happening in the nation and in the world, I want to say first, thank you for giving us a little bit of latitude to reschedule this away from our original date, because we felt it would detract from the national conversation that was happening. Second, the reason why we're still having this event and why I'm actually excited to share a little bit about it is that as part of a business resource group in IBM, we get to define what our mission is. And one of the things that we do every year is we set out and say, here's our goals. So for 2020, our goals for the resource group were to set up and tee up opportunities for professional growth. They were to do community outreach and embrace the community. And they were to find opportunities for personal vitality for employees or their families. So when I talk about pride, we talk about pride sometimes in a little too narrow of a focus. We talk about it in the context of LGBT pride or some such, but in reality it's about the broader community and having support and allyship and helping others do what they're going to do and be great at it. So in that vein, I want you to kind of listen to this in a slightly different context and think about it from the perspective of me as a person that knows a little bit about a given piece of technology, trying to help everyone here either have a discussion, to learn something new, or meet someone new that may help them in their future endeavors. So with that said, we'll get into the main content and talk about the actual main body of this. So hey, let's talk about context for computer vision. Computer vision, when you look at any sort of courseware, will almost always come back to an example or a homework or a project that will be helping to determine dogs from cats or some such. I think anybody who's taken a course in AI or deep learning has probably done something along those lines and probably has a directory or a folder on their laptop with a bunch of kittens or puppies in it. Or they might have the MNIST data set, which is the digits 0 through 9, or something more fancy. Computer vision is actually way more than that. There's actually kind of a lot going on, and it's a pretty advanced field. And we're going to talk about a little of what's possible there, and then also look at the technology in a particular example and show how it works and how you can actually leverage that for your projects or for your business or just for fun. So computer vision really can be found everywhere, from large companies to high school science fairs. One of my teammates actually, her son submitted a project that I think made it to state level, if I recall, that was using a TensorFlow model to go out and look at satellite or aerial photos and find great areas to play a game or to play outside. The idea being that a park may be labeled sometimes on Google Maps or Apple Maps or whatever tool you're using, but sometimes a great green field is a great green field, and it can be a great soccer field if you want it to be. So they wanted to try to look at those things and try to find those in their neighborhood and make something out of it that I think was pretty neat. You are probably all quite aware of it, but your phone indexes your photos by content. So if you go into an iPhone or an iOS device and search for puppy or kitten or cat or dog, there's a pretty good chance that it's going to find your puppy or your friend's puppies, your family's puppies, or your cats or dogs or what have you. That's using computer vision and AI and deep learning to do that. Social media sites, as I think we're becoming more and more aware, are able to actually look in the content of images to actually understand what's being used, and you can do the same thing there and more. And we've even had examples of science fair projects to work in a medical domain around trying to determine the best way to detect melanoma. In all of these examples, for every single one, are countless companies or individuals or potential projects that have yet to actually utilize computer vision. that's sometimes for reasons like they don't know how much work it's going to be, or that's for reasons like they don't have the data, or they don't have the pipeline, or they don't have the expertise to be able to apply what's necessary to get from start to finish. So what I'm going to share with you over the course of this particular meetup is how to break down those barriers and work across the different parts of that team. And by the end of this, I think, give you a little glimpse of what's needed and what's possible. So IBM defines that problem, that idea of trying to work with AI or bring AI into a given problem space as ascending the AI ladder. That ladder is made up of rungs, which we actually also show here on this figure as pillars on the right side. But those rungs are things like preparing data or just simply acquiring your data, building models that are deep learning models or machine learning models, running those models in some form, and then managing them at scale to bring the fairness that we all demand. And we do that built on top of infrastructure that's plugged into all parts of a given piece of technology. And we build on top of those application-specific things that are in a given domain or in a given space, like esports even, or actual sports, or both. So IBM Visual Insights spans that AI portfolio. And our fundamental idea is that we want to bring a single modeling architecture and give you any inference solution. And what that means is that you can bring your stuff, and then when you take the model at the end of the day, you can run it wherever you need to run it. And when I talk about computer vision models, it's important to get more specific about that, because when I share, I work on computer vision, or I work with AI, or hey, there's this cool thing we're doing with AI, people sometimes get a little hung up in what they've seen in movies or what they've heard about in the news, and some of that's a little bit sensationalist, or some of that's frankly not possible, or some of it's just old and we can do better. In this case, it's helpful to lay out exactly what we're talking about in terms of the computer vision tasks that we're going to address. So what I'm sharing is actually a slide from a great series from Stanford. That's one of the seminal kind of references that a lot of people go back to. But this is CS231 from Stanford, one of their just intro slides partway through the lecture. But they do a great job of explaining that computer vision really can be broken down into different types of tasks. So on the left, you see classification. This is what you may have done if you've done a intro to ML or intro to AI class, where you give a picture of a cat or something, and the model can, at the end of the day, tell you cat or dog or puppy, and that's it. It can't tell you where it is in the image, can't tell you how many, can't deal with multiple things, but it can tell you, given a cat, this is a cat. There's kind of a secondary task that comes with that, which is localizing where in the image the thing is. So that's that little red box they show in the second from the left. There's a very different task called object detection, which says, given an image, I want you to tell me what's in it. So object detection is different from classification in that we say for object detection, hey, tell me where these things are by pixel coordinates, and I'll give you a bounding box where that is, and then tell me how many you found. So where in classification I could say this is a picture of a cat, in this case I can tell you this is a picture that has 2 cats, a dog, and a duck. And there's even a more fancy example, which is segmentation, which says, hey, I want to tell to the nearest pixel where these things are in the image. The Visual Insights application enables you to build models for all of these and some more, and we all do it through a website, which I'll share with you in a few moments. Now, anyone who's worked with AI or is a data scientist or has done coursework in this space will be familiar with data science workbenches like Watson Studio that I'm sharing here, or Jupyter Notebooks or Jupyter Hub or other things. I share this because we very much don't expose notebooks. We don't work with notebooks in this application. We're at that higher level of that software stack. We build on top of the pillars, the foundations that someone might use from a notebook, but we do it kind of at a more abstract view. So if I were to try to build up a model using, from scratch, one of the machine learning frameworks, I'd probably have to pop into Python, pop into Notebook, start fiddling with my data, get my data to be in an okay state, then get my model to be in an okay state, train my model, get my model to work okay, and then eventually I'll have this giant notebook that will eventually make sense to someone sometime, but will take a while to kind of work through. Once I've done that, I then have the task of taking that model that I created and through copious Stack Overflow and Googling and looking around and banging my head against the wall, eventually write some code that uses that model to go do something. So I have to do a lot of work to kind of pick up and then run the model once I want to run it somewhere. At the end of the day, when we look at the technology, this is actually part of a broader set of problems. So if I back that out a little bit and look at it from a more holistic view, I can actually kind of take you from those two data points to kind of the broader data science team and say that fundamentally, data science is a team sport. It takes more than that data scientist or that data engineer who's got to work in the realm of notebooks and work with cleansing data. It takes more than that software developer who has to go write the app or write the website or write the tool that will leverage that model. It takes more than that analyst who will label the data, whether that's drawing boxes of puppies in pictures or labeling data in an unstructured format. And it takes more than that line of business user who's actually going to go do something, or that end user who's going to go do something to make a decision based on the output from the model. In this broader data science team, you don't want to be the person that's holding up everybody else. Likewise, you don't want to have your entire team frozen because they don't know where to start. So we, through the ascending that AI ladder that I told you about, walk our users through this process from start to finish, and we help each of the different parts of this team get what they need done as quickly as is possible. So the Vision application really works through those 4 steps, but I think it's more interesting if I just tell you and show you kind of what that looks like. So I will step out of here and go over to here. So this is our Visual Insights app. And what you're looking at is it running in a browser. I've got it popped open. And I told you those 4 steps, right? Working with data, labeling your data, training your model, deploying your model. You see the same 4 steps from the AI ladder here. If I click on Get Started and I take us into a specific domain, I'm going to look for USGP. So for anybody that knows Austin, Texas, you know that we love our events here. We know that we love doing stuff outdoors when we can, if we can. And we know that once we get through all this COVID stuff, we're going to look forward to getting back together and doing all the really great things that make these great festivals and events possible. One of those is the US Grand Prix, which is down south at the racetrack, Circuit of the Americas. So I want to share with you an example of working with data from this kind of race domain, sports domain, and show you what's possible with it. So what I have is I have a video that I pulled in. So I've got a video that's in the platform. And what I'm sharing is I'm sharing an example of that same video pulled into my tool, and you can kind of see down here I've got just different frames kind of pulled out of it. So when I look at it, this is a 6-minute highlight reel that just came from the internet, nothing special about it, no extra annotation, no secret sauce, no nothing. This is just a video of some cars going on a track. And what we did is we pulled out from that frames from that video. So if I kind of scooch along here, I think I can find where that was. It's probably right about here-ish. So we pulled out frames from that video and we started labeling things. So I started labeling different cars. So I know that this is a McLaren Honda, because it's orange and black. I know that this is a Force India because it's a bright pink. And there's a Ferrari for its bright red. And if I got this right, this is a, where is my Renault? Back here in gold and black. So those little boxes I was dragging and dropping are labeling. Every time I let go of my mouse, that was sending back a label to our data set. So I repeat that process several times more, and after doing that for about 150, 200 frames, I can train a model. So if I look through here, you'll see that I've done different examples of labeling the different cars in the scene. So when I go to step back and I train my model, this is the first time we ever actually share anything that has to do with deep learning or machine learning in this application. We ask the user literally at a big animal sort of view, what are you trying to do? Are you trying to classify images? Are you trying to find objects? Or are you trying to detect actions, which I haven't even talked to you guys about, but we can detect actions in video too. And once I pick one of these, I'm given a bunch of different model types, and I can choose, which deep learning model architecture I want to use. So we actually build in faster RCNN, YOLO model, so that you only look once, Detectron, single shot detector, or you can even bring your own custom model in too. If I hit the train button, that will kick off a training job under the covers. And if I go look at it, I'll actually just pop one up real quick that I did earlier and share with you what it looks like. So that model, if I let it train, will actually produce for me a bunch of different things. One of them is, how good is this model? I can look at a confusion matrix and see, hey, given all these different things, given what I believe is a true F1 Haas car, how good was the model at predicting this was actually an F1 Haas car? The whole idea of a confusion matrix, this is probably my favorite stat, by the way, for this kind of deep learning task, is that I should see for every example that it got it right. So I should see a perfect 1.0 across the diagonal. I chose this one on purpose because we stopped the training early to see what it looks like. And you can see the model was able to pick up even early that bright pink car really easily. It was able to pick up the bright red Ferrari really easily. It got Red Bull really easily. But it had trouble with Williams, that's a white car. It had trouble with picking up certain other things I labeled here. It had trouble with getting Renault. So I can look at this and I can tell, oh, I need to do a better job of training, or I need to do a better job of labeling my data to try to make this work better. So I can iterate a couple of times, and eventually what I end up with is I end up with a model that looks like this. Oh, I am on the wrong machine, but I'll deal with that anyway. So I end up with a thing that looks kind of like this. So if I go to my USGP model again, and I deploy this one instead, and just give it a sec, what you'll see is we'll spin up that model, and under the covers, what we're doing is we're actually creating a REST API that's going to be dedicated for running this model. So we will create a Kubernetes pod and do all the cool stuff we got to do, and then present it, and there we go. And I have an API here that I can go hit if I wanted to. That is the actual REST API under the covers. So if I find my USGP stuff here and bring some random frame in and drag and drop it, what you'll see is that, hey, we did all our inference on this thing, and I labeled all these different things, so I can now get from this image that there's Rolex ad, the different teams like Mercedes here, Ferrari here, Red Bull, Force India, and so on and so forth. So this is, kind of a lot going on, right? This is, This is saying that I can take a model that's a generic deep learning model. I can customize it and fine tune it and train it for a given domain, and I can then bring it in and I can drag and drop it and make it work and see if it actually works in this example. And what's even cooler is that everything that I just did is all available via REST API. So when I look at that same exact thing for a different frame, I can hit that same thing. I can look at the response and get JSON back that shows me the Mercedes cars, the Force India car, Ferrari, so on and so forth. All as just a JSON array. So let's actually look at what's possible with that. You know, think about the fact that I can now take a video, I can label these objects, and I can get something, right? So go back to my data science team that I shared a little while ago. That's only part of the problem. The model is only a piece of the problem. It's not actually solving, at the end of the day, the actual business use case. It's not helping to give an insight to somebody. It's not helping someone to make a decision. So let's look at this in the context of somebody who's trying to make an advertising decision. So imagine that you are an advertiser. You are trying to spend a budget of however much money, and you want to make the most bang for your buck, which I'd hope you'd want to do anyway. And you want to try to get the most for your advertising spend. If you've never been out to Circuit of the Americas, it's a massive track, and they will put a logo on anything. So you have a lot of opportunities, right? So if I want to spend a certain amount of money and get the most bang for my buck, how can I use the advertising impressions of what actually made it on TV or made it onto YouTube or made it out on the broadcast to figure out what really is going to be lead to the most possible impressions that'll come out. So let's look at that model applied to a video and start answering that question. So what you're seeing is that same highlight video. But what I did is I'm painting on top of it. I'll pause it real quick. Oops. And we'll go back over here. I'll paint on top of it these little dots. So if I let it sit for a second for the webcast to catch up. And I'm painting little dots to say, here's the objects we found. So imagine for bounding box, every little dot you see there. And in the upper right corner, if I hit play, what you also will see is that we're keeping track of how often that object was on screen. So you'll notice I have the upper right corner, the team screen time, so how often do I see a Mercedes or a Ferrari. And above that, I have the advertisers in the background. So Rolex, Pirelli, Heineken, DHL, Suzuki Komen. So I can take a very simple thing, which is how often was this object on screen, and I can start answering much nuanced questions, like how often was an Emirates ad in the background, right? I can start saying how much screen time did Mercedes really get? And I could even do things like, you know, given that I've got a 2-hour broadcast, how often was Ferrari on screen with Rolex at the same moment? So all of this is possible because we took that kind of holistic view of labeling our data, making that labeling something that someone who's an expert in F1 could actually do very quickly, making that something that they could train a model very efficiently, and hand to a developer who knew the domain of advertising to be able to then do things like the screen time roll-up that we show here. That entire concert of everyone working end-to-end together is, I think, really crucial and really important. So let's take a little closer look at this. And as I said, feel free to ask questions. And Jenna, if anyone's got something, please feel free to interrupt me, and we'll kind of go into it. But I want to share a little bit about kind of how this stuff works and how we might leverage it.
We have one quick question. Someone asked, is Visual Insights in the IBM cloud? I can only find visual recognition.
Great question. So yes, but it's not available as a microservice. So the visual recognition microservice is exactly that. It's designed to be a pre-trained model or a way to train a custom model for your end application. So it is very much driven by developers for developers. And the whole idea behind that is to leverage your expertise in writing apps or writing websites or writing applications and leverage the Watson platform for running the underlying model or creating the model and running it somewhere else. In this case, the Visual Insights application is designed to do a little bit of a different thing. It's designed in a way that's actually more tailored for on-prem applications or private cloud applications, or you standing up your own dedicated instance inside IBM Cloud, which we actually do. In fact, the one I was sharing with you was actually on Cloud Private. That's actually where I was hosting the thing I was just clicking around just a few minutes ago. But yeah, it's actually out there. And if you watch this space over the next couple of months, we're going to, or at some point, excuse me, we're going to make some announcements about availability and stuff. One thing we actually did do, which is public right now actually, is you can actually go out to one of our partner catalogs. So if I go to NVIDIA's NGC, NVIDIA had their GTC conference just a little while ago. We made a little bit of noise with them in this space because they announced their NGC catalog had different assets in it, like Helm charts, containers, models, and stuff. If I go into Helm charts, you'll see that we have our IBM Visual Insights Helm chart sitting out here. And you can actually go and roll through this and stand up the same exact software I was running. It'll be trial instance versus production instance, obviously. But you can do everything you want to do to spin it up on top of your own Kubernetes, or even run it on top of AWS or IBM Cloud or Azure or GKS or whatever you want. If you want to run a kubelet on your laptop and you got a good enough GPU, more power to you. But yeah, that's kind of the direction we're coming at in terms of platform availability. So that's a great question. So yeah, keep questions coming. You know, we can talk about whatever you guys want to go into in terms of detail. One of the things that's interesting is that you know, as a person following the space, the AI world moves incredibly rapidly. I actually have two different things on the screen here. On the left is a paper that's called YOLO v3, an incremental improvement. And if you're reading while I'm talking, I'll give you a chance to kind of do that. But this has got to be one of the most interesting papers to read in that it is, on the one hand, brilliant, and on the other hand, snarky as all get out. And it's also referenced by so many other people. So anyone who manages to write a paper that says sometimes you just kind of phone it in for a year, you know, and then they end up producing something that's extremely high quality in terms of technology, I think you got to see has a little bit of swagger, and you should probably give them a second look and kind of see what they're talking about. The YOLO paper I have highlighted because this technology, this idea, this single shot detector, which is what this kind of is, it is something that's evolved rapidly over time. And in fact, just Monday or Friday of last week actually, someone actually put out a paper or a model, excuse me, that they called YOLO v5, which followed a model that came out called YOLO v4 just a month prior by someone else yet again, both of which have nothing to do with Joseph Redman. And in fact, there was drama about YOLO v5 because there was no paper, there was no stuff, no proof, and so on and so forth. So there's a lot of interesting intrigue happening there. I highlight that because what we see with things, even in the text space, are that there are many, many, many interactions and derivations of technologies. So where I've talked about computer vision for the last 40 minutes or so, there's a similar renaissance happening around text analytics, all due to a model called BERT, B-E-R-T. And of course, nerds being nerds, geeks being geeks, that means that we went from BERT to BioBERT to VideoBERT to SciBERT to Ernie, which I thought was clever, to Roberta, each of which is a different variation of the fundamental concept of that particular text analytic model. But it's that combination of being able to iterate rapidly and pull data from different places and experiment that results in this. And what that means is that in both cases, the state of the art moves. The state of the art changes from day to day, week to week, month to month, which means that every kind of core principle tenet of the deep learning pieces of this stuff are going to change. So that's why when we look at the application in that broader data science team, we talk about and we solve the problems of that broader data science team on purpose for the simple reason that we want to be able to swap in and swap out different model types and model architectures as we as an industry get smarter and have our end users in that broader team take advantage of it. So if I look at the history of this project, we actually partnered with our IBM research colleagues way back in 2016 to prove this was even viable. We made technology previews across 2017. We shipped the first version of the product in 2018. We then, over the course of almost every quarter, did a feature bump that added new capabilities and new content and new function, which means that we kept turning the crank on different layers of that application stack, from the fundamental deep learning layers to our integrations to even things like support for extended inference of models on end devices like an iPhone or an iPod Touch or an iPad. So at every layer of the stack, from user experience to GUI to the core application to the deep learning layers to our edge inference, we've turned the crank in some form, and we'll keep doing that. So if I look at the idea of kind of generically, what does this take to run, under the covers, you know, there's a paper that Google put out a little while ago that they tried to very clearly highlight, you know, the complexity of running a deep learning model is not the model itself. It is all the stuff you need around that model. It is collecting data, validating the data, running the machine underneath everything, looking at and analyzing the results, serving the model, doing things to manage the overall infrastructure end to end. And at the end of the day, this tiny little model is only a tiny piece of the work. So the Vision application that I told you guys about, the Visual Insights application, if I were to show you its internal architecture, looks a lot like this. I mean, it's a lot like this. I joke around only kind of a little bit, but you know, I say that, you know, we've got a couple thousand lines of deep learning code and 250,000 lines of a website. That's basically it, right? And that's because we do all the things to manage that user experience. We do all the things to manage the data. We do all the things to manage scaling and all those kind of things, to hide that from that broader data science team again. So when I take you through this end to end, this is kind of my wrap up of where things are, and we'll go into Q&A at this point, I hope. You know, when we go through this, at the end of the day, we want to help our users down this journey. We want to help them to work through their data. We want to help them to be able to prepare their data, build models, train those models, and then bring them out and bring them into production. And in reality, we're doing a little bit of a focus on that earlier part because, as I said, we want to help people get started. So that's where I want to kind of shift into talking through a little bit of, you know, Q&A, frankly, first, and then go into a little bit of kind of what you need to do to get started here. So, Jenna, do you have any more questions, or if people don't have questions, please add them into the Q&A, and we'll go through them. Do you get anything out there?
It doesn't look like we have a question right now. But yes, please add either to the chat or the ask a question, and Mike will be able to answer it for you.
All right. So let's talk into some concrete tips on how to do this stuff, right? So I wanted to for each of these 4 things just leave you with something that I think might be actionable. Obviously, you can go if you go ahead and just Google Visual Insights and go to our landing page. You'll have a link you'll get to at the very end. It's either going to be to spin it up in IBM Cloud, or to just sign up and we'll give you access to an instance that we'll manage for you. So you can get going with the app, by the way. But first and foremost, you want to manage your data, right? You want to actually create a model that's based on good data. So you want to make sure that what you have is actually valid. So you need to be able to manage those assets in a data set, and do the thing I did: label little boxes, or draw polygons, or do what you want to do to manage your use case. But you need to be able to work through that and create a workable data set that will be useful to you. Now, there's an open secret in data science called data augmentation. Data augmentation is actually built into a lot of tool chains now. Like you can just flip a flag on for a lot of different things. But sometimes you have trouble where you only have 5 examples of something like maybe my maroon car is a rare example, right? I don't have many maroon cars in the wild. So I may have hundreds of black cars, but only a few of the maroon ones. So I want to take those examples that have the maroon ones and augment the data set with those. So I might actually zoom in and just crop it down to just the maroon car. Or I might try to find those and do rotations on them or something like that to help kind of balance my data set. When training, again, people get hung up on the deep learning parts, but I don't want to diminish in any way the work that goes into data science, but at a certain level, users don't need to know how the network actually works. They just need to know to trust it and know how to look at it and know how to trust or distrust the results that come out of it. So for our advanced users, we actually offer a lot of hyperparameters and kind of the fine-tuning things you need to do. But at the end of the day, we want to make it something where you basically label your data set, hit the training button, come back and look at it, try it out, and realize, oh, it's gotten it wrong, because you can see the little diagonals wrong or whatever it is, and try to fix it up as quickly as possible. At the end of this, you want to get to a point where your model is as good as you think it can be for your training set. But in reality, that is going to be an iteration. So you may actually try different things, like trying different network architectures. Like you may try our single shot model, or try our Detectron model that does polygons, or you may try different trade-offs of performance or things like that. So because we try to make this easy, you can kind of do those what-ifs fairly quickly inside the application. And then finally, once you got something that you think you trust, you want to try it out. You want to see how it works. Like I did my little drag and drop onto the GUI. But you want to test it. You want to validate it against a real data set. And that validation is a point-in-time example of does it work or not. But in reality, the real world is actually sometimes very different from your test set examples, right? I actually can offer 2 different examples of this. First is from when I was in college. One of my friends was doing a PhD actually in autonomous drones guided by computer vision, and was doing a project, and something happened over the course of the year where she couldn't defend her thesis, or defend her dissertation, excuse me, in the spring. She had to wait until the fall. So her drone was able to fly around, do whatever it needed to do, and it was great. But by the time she got to it in December, the drone took off, flew around, and promptly flew into a tree. Now, can you maybe guess why in December in Oklahoma, a drone that worked fine in the spring would maybe have a problem in the fall? In this case, it was the fact that all the trees in the data set had leaves, and it just wasn't equipped to understand that a tree branch or a bunch of tree branches is still a tree. So that data set didn't match up with reality. So that that example is actually a really kind of interesting one, in that, you know, it says that there's going to be this idea of retraining, or this idea of updating or refreshing that model over time. And you want to notice when that's happening, and, you know, prevent your project from flying into a tree, hopefully, or whatever the moral equivalent is. If I go back to my US Grand Prix example, I'll actually show you something. I'm going to go back into that video real quick and look at it a little bit closer. I like this because this is actually an example of bias. We talk about bias a lot, especially recently, in the context of human beings, and fairness in the context of computer vision around detecting people and understanding all sorts of things about them. But I'll show you a different example. In this case, if I pause this video and go back, look closely at this. I've labeled my teal Mercedes car here, right? And you'll see my model is thinking this is also a Mercedes. If I play this clip back a little bit more, I actually left this area in on purpose. What you'll see is as that car clicks from the side view to the rear view, it will at some point decide that's a Mercedes. And I'll tell you why. We actually figured it out. You can see it doing the same thing from the front view here. This is actually a problem in the data set, and it's a bias induced by the data set. And that's because our data set is based off of a highlight reel that was cut by a human being to tell the story of Ferrari, Mercedes, and Red Bull duking it out for first place in this race. So because my data set took point samples every so many seconds, just periodically, for all my labeling stuff, I have a bunch of examples of chasing shots of the Ferrari and the Mercedes car, where Merc was out ahead because Lewis Hamilton is great, and it's Lewis Hamilton. But we have a lot of shots of back and forth kind of things of that Mercedes vehicle with other things, other vehicles. So what that means is that I have actually an abundance of these Mercs that are shiny and super bright, and therefore things like this shot back here will bias my data set, because from this view I can't see the paint anymore. And from this view, this car that I labeled as a Mercedes, because I know it's a Mercedes because I watched the video, ends up tilting the model to think that anytime I see a car shot from the rear, or anytime I see a shiny car shot from the front, it's probably a Mercedes. So how do I fix that, right? Like, how do I actually resolve that problem? So you can actually see it here as well. So how do I resolve that, right? That's actually something that we can expose, and we can see that in that confusion matrix that I popped up on the screen. But at the same time, the resolution is to change my data set. It's to go back and you know, add more examples of other vehicles that are also shot from that same perspective, or to ensure that my data set's balanced across all the different views of the different vehicles, so that, you know, it knows that there's a more likely chance of seeing other types of vehicles than just that one. So I mentioned that because that broader workflow that I showed is actually an iterative workflow. We expect users to build models, train models, evaluate models, deploy them, and then eventually step back and do it again and again and again. We expect them to iterate as things change. And we want to make it easy to do that, and we want to make it something that's painless to do. So we built that into the application, we built it into the workflow. So all of that I kind of leave you with to say that, at the end of the day, you get what you put in, so garbage in, garbage out. If you have bad data, you're going to get bad results. You want to make sure that your models represent a diverse training set, or are represented by a model that's built on a diverse training set. You want to use real-world data. Obviously, you can use synthetic data in some cases and get away with it, but you want to use data that matches up to real world. I'll even give a different example yet again. If I were to go look at a theme park a year ago versus a theme park at some point when they reopened, I can imagine that cast members or employees or team members or whatever they're called, the people that are working in the park, are going to look different from 12 months ago to in the future. It's going to be because styles have changed, tastes have changed, but then also they may be wearing masks because it's part of how things are going to go for the foreseeable future. So we have to be able to react to that and very quickly rebuild things appropriately when that happens. And finally, you want to make sure you choose the right model for your problem. So if you are trying to work through detecting when something's on screen or detecting when something's in a scene, that may mean that you use a classifier and you're great, you're happy, and it's easy, and you go. In some cases, you may want to know to the pixel, where is this thing on screen, because it matters to me a lot that it's in this area or not in this area. That's where you'd want to use something like our segmentation models or something along those lines. So I will kind of end things there, and I'll offer up to do a Q&A, and we can go back and forth on whatever y'all want to talk about.
So we have a few questions here. The first question, kind of going with the talking about bias and kind of hitting the tail end of that. So what are some ways of addressing and or preventing bias in your data sets? And how can you tell when you have bias in your data set?
Great question. So first, to address bias, I actually mentioned one of the things there. It's using things like data augmentation. We're trying to ensure you have what I might call a balanced data set. So for computer vision style use cases, that's kind of something like, hey, I should, in the broadest possible sense, I'll actually pop out and I'll show you from the GUI here. Let me step back and look at our USGP example again. So on our left-hand side, you just want to say, hey, do I have roughly the same number of examples of these things? So I can actually see that in our advertisers, right? If I just filter down to just the advertisers here, that I have a bunch of Pirelli, huge number of Rolex, and not enough Susan G. Komen examples, right? So I can just kind of look at it and tell, yeah, there's something not right about this because this is not balanced appropriately. And for the style models that we're using, which are going to be some form of a classifier or object detector, and if you look at how a lot of these model architectures work under the covers, there's something called a backbone network in the model architecture that is looking at a bunch of different features in the image, where a feature might be a learned thing like this little bit here that we're looking at, that's the nose of F1 car, or that DHL has yellow and red in it, so those might become features in the model, right? That backbone network is then going to say, okay, I want to find all the things that kind of trigger these features, and then at the end after that decide, okay, where are the corners, or where are the pixel masks, or what have you. So for this style model, you need to have a relatively balanced data set. If you want to detect this kind of thing, I'll show you an example of a really good model, paperclips. Paperclips ought to be great. No, paperclips are not great because they're a different model that I want to share with you in just a sec. Probably this one. No, sorry. I'm going to pick a different one. How about face masks? So face masks, we want to do something with this data set, right? So this data set, I'll pop into it. I'll show you what it looks like. This is just a toy we have, but we want to see, hey, are people wearing a mask or not wearing a mask, right? This is just an internal thing we're using to try out the software and kind of see how the application works. But this matrix that I popped open, you can see very clearly in this matrix that it does a pretty good job of detecting when someone's wearing a mask, because if my true label is wearing a mask and it predicts wearing a mask, hey, it's not bad. It's 50-50 though on being able to detect when someone's not wearing a mask, and it sometimes seems to think that they are improperly, when they're improperly wearing a mask, they're not wearing a mask at all, right? And it has a bad job of trying to detect and correctly score when someone's improperly wearing a mask. So I can see in this data set that I have a labeling problem, most likely, or a data problem with this. Now, the interesting thing about this is that if I go look at these classes of objects, again, I can see the same kind of thing where it's imbalanced, right? I've got 400 some odd examples of that and only a few of these. And then I have an interesting kind of judgment thing, right? So what is an improper wearing a mask? Is it that her nose is exposed, right? It's that, it's not covering someone's face appropriately. And then, in addition, when I look at the no mask example, I've got examples of people that are partially occluded, so I can't see their whole face necessarily, but they're still labeled as not having a mask on. So I have an interesting problem that comes up from that, and you can kind of start seeing that in this data. In addition, we actually break out something called a precision recall curve, or PR curve. The PR curves are supposed to be basically a flat line, and then it's supposed to kind of fall over on a plateau at the very end. And the idea is that the model is able to correctly discriminate when it should or shouldn't say something is true or false and stuff like that. There's a very mathematically correct answer that I can never recall offhand, that I have to go Google and look at Wikipedia every single time, but basically it should look like that. So these two things come together and kind of start telling us the story of when is a model not behaving right, and then we can do things like manage the data set, or at the end of the day, if you can't manage the data set, this may just be a problem that you can't solve with this particular type of technology. So too bad, so sad, move on. So hopefully I answered your question, but I will pop the chat open so I can try to see other stuff too. Are there other questions?
Yes, so someone asked, does it include tools for explainability, as in the IBM Visual Insights? Does it include tools for explainability?
Yeah, so we do that a couple of different ways. So one is this this kind of view of the model. We don't actually have a look inside of the model architecture. That's actually on our list of things to take care of, but we haven't done that yet, built into the pipeline. There's a piece of software which is our OpenScale portfolio that literally that's the entire thing they do. And one of the items that's on my list is to go have a chat with them to figure out the right integration points to hook into OpenScale in a way that would make sense for us. the best we do right now is we do have, based on training, if I go back to my training real quick, I will share with you kind of one thing. If I pop on advanced mode, for almost all of our models, I think every single model, I have hyperparameters that I can expose. One of those is a ratio number, which at the end of the day is used to control from a given data set how many images we hold out to use as validation images. So what we'll do is we shuffle up the user's data set, so it's random, and we say, okay, 20% of that we hold away from training, and we use to say, is it working correctly or not? So we have a little bit of that, but not everything there. Other questions?
Yes, so there is a question from while you were doing your presentation and demo. How much of an impact does lightning have on training if we're talking outdoors, like morning, cloudy day, sun, dusk?
It has a huge impact. That's actually where a lot of people fall short, and that's part of why we built the application the way we built it. So I'll give you a great example of that. We actually did a engagement with a telco provider who's a 5G telco provider, who was trying to show how the combination of high bandwidth, low latency networking, and AI and computer vision would enable you to do different things. And they basically have a demo center in their office. So it's like a proof of concept thing. And based on proof of concept, then they'll roll it out to other places too. So we did a thing with them where we trained a model to detect hard hat. So you can imagine my little dude here wearing a hard hat and safety glasses and a few other things too. It worked like a champ until someone tried it out on a sunny afternoon in the summer, and because of how the sun had shifted over the course of 6 months, the sun was shining right through onto it, and all the colors got washed out, and it just messed up everything. So yeah, the models are very sensitive to the changes in lighting and things like that. One of the things that we do have is, I mentioned that idea of augmentation, right? So if I go in here, I actually have an extra little button. It's my data augmentation button. We do something a little bit different from other platforms, where other platforms might randomly shuffle augmentation every single time. We actually will generate a brand new data set based on the random shuffle, and we'll keep it that way so it's deterministic. So I can do things like mess with brightness or mess with contrast or do hue shifts or saturation shifts to try to make the thing more resilient to those changes over time. But absolutely, that's something to pay attention to. And it's something that very often will trip up people, because something will appear to work, and it'll work for a while, but as they get more and more adventurous, they may discover, or as their users become more and more adventurous, they may discover that stuff isn't quite as perfect as it seems.
We have another question. Someone asks, does machine learning like this mean image recaptchas are no longer secure?
Sort of. It depends on what you're doing with it. So you'll notice that things like Recaptcha, if you've gone through that, they actually keep moving the ball on how that works. They keep changing it on purpose. And in fact, I think the most recent iteration, it'll just say, hey, are you a human or not? And sometimes, for whatever the input reason is, I don't get my images. I just get my little checkbox. It becomes a yep, and I move on and I keep going. When I do that, though, sometimes I'll get a challenge that says, hey, find all the fire hydrants, or find all the crosswalks, or find whatever in the image and tell me what those are. Those are training a classifier. At the end of the day, that's what the data is being used for. It's helping to build bigger, faster, better data sets. So you're being a free labeler. So it's part of the price you pay for having no bots in your property, or for accessing some website. But those images are challenging, and they're used on purpose to try to A, label difficult data, and then B, it is intentionally something that might be difficult. So yeah, you could use this to try to pick out something and trick a CAPTCHA bot. But whatever you're doing will probably very quickly you realize you'll just be bumping up against a raised bar from whoever's running it, whether it's Google or somebody else or whoever, it doesn't matter. I would highly doubt that you'd be able to build something that worked efficiently and effectively for any sense of real scale. Got other questions?
I think those are all the questions we have that have been posted so far.
Cool. So let me kind of go back in here real quick, and I will leave you with something interesting, which I will pop up on my screen here. I will put this in the chat if I can find where my chat went to. So this is actually a video that one of our partners and clients put together that is a example of our advertising or our action detection model. So it's actually out on YouTube. But what I'll do is I will maybe hit play here and see. I actually should have checked this, but could you guys hear the audio for that?
No.
Okay, that's too bad. Yeah, I'll have to figure out how to do this later, but y'all can watch the video here. But at the end of the day, this walks through an example of using action recognition to actually build up a set of dance moves that eventually a choreographer strung into a dance, which is pretty cool, using our stuff. So that's pretty much it. I want to say thanks, everybody. And I'll hang out and we can just type back and forth if you want to ask any more questions. Jenna, I think, do you have other things you want to wrap up with?
Yes, I'm going to share my screen.
Perfect.
Go. Where did it go? Aha.
And thanks y'all for hanging out, by the way. I should say I appreciate it and giving interesting questions.
Yes. So here is the link. And again, I've included at the very top of the chat all of the links. All of the links are within the slides. So if you have the link for the slides, I'll repost here. You will have the links for everything else, including a copy of the workshop slides. There we go. Okay, I'd like to say thank you to Mike for giving us such a great insight into computer vision and IBM Visual Insights. I would also like to thank all of you for coming out today and joining us, taking the time out of your busy week to hang out with us tonight and learn something new, asking some great questions. If you enjoyed the session today and you would like to learn more and attend more sessions like these, I have lots and lots of links here for our social, so you can connect with us connect with our events and see what's going on Meetup. So we have IBM Developer Austin, New York City, and San Francisco. We have other events going on as well. You can also connect with us on Twitter and Twitch and YouTube. We have IBM Developer channels for all of our social. Oh, you know what? Right here. This is what I was planning. You can connect with me on social at jwritten. My handle is jwritten on any platform. So if you do anything /jwritten, I will probably find pop up. I've posted links to connect with Mike on Twitter and LinkedIn as well. So feel free to connect with him there. Also, you can take a look at the link that Mike just posted, how to get going with Visual Insights. There's 2 links there, and you can give it a try. Register for a 30-day access to IBM Visual Insights on IBM Cloud, and you can download a 90-day limited evaluation of IBM Visual Insights for Power or for x86. Again, I would like to thank you all for coming. I hope you learned something new. I hope you were, it was insightful. I hope some of the things that Mike discussed with all of you were able to provide some impact for you in a number of ways. If you would like to learn more about the IBM Allyship Badge, those are in the slides as well. I'm also posting them here. There you go. So I highly encourage you to check that out. We're going to have some great events next week in celebration of Pride Month as well. So I would encourage you all to check out IBM Developer Austin to register for those. And hopefully we'll be back soon with Mike to bring you all another great talk on computer vision and deep learning and all the buzzwords and all the cool stuff. So thank you all for coming, and we'll see you all next time. All right, cool. See you later.